All right, so quick review of how to use the one-to-one property with exponential functions, but then we're going to use that in order to solve logarithmic equations. So that's our main goal today, is we're going to look at how to solve logarithmic equations. Then tomorrow we will, day 2, I guess I should say, we'll look at exponential equations, ones that are more complicated than this. So keep in mind, we're not going to actually look at this challenge problem yet, or number 2. I'm just going to do one quick example here. Reminder that if we can, we rewrite the base so that it's the same. So 4 squared is equivalent to 16. And so now we have the same base. And so now we can distribute here, and we get that 2x plus 6 is equal to 4x plus 7. And we're going to solve. So when we solve here, we subtract the 2x from both sides and get 2x. We subtract 7 from both sides, and we get that 2x is equal to negative 1. So x is equal to negative 1/2. So remember, the key for this one-to-one property is that we rewrite so that the bases are the same. We're going to use that same idea with logarithms as well. So that's what we're looking at next. So if you notice, we have to use our properties here also. So on this right-hand side, we can rewrite this right-hand side as the log base 2 of 10 over x minus 4. So we have this. We have the log base 2 of 5 is equal to the log base 2 of this 10 over x minus 4. So if you notice, we have log base 2 of something equals log base 2 of something. So clearly those somethings have to be equal to each other. So I think for convenience sake, to help you see how we would solve this one, because there's a little bit of a trick on this, we're going to set that equal to each other, and I'm going to write the 5 as 5 over 1, just to help us see that we're going to cross multiply here. So we're going to do 5x minus 20 is equal to 10. So we get that 5x is equal to 30, or that x is equal to 6. So that's the one-to-one property. The log of something equals the log of something, then those somethings have to be equal to each other. So similarly here, notice we have log base 5 of this equals log base 5 of that. So clearly then, those highlighted parts have to be equal to each other. So now we have this quadratic that we need to solve. So we factor, and we get x plus 5 times x minus 4 equals 0. So we get that x is equal to negative 5 and x is equal to 4. And we do, remember, have to go back and check to make sure that we do not get a negative argument. And we do not in either case. So both of those check and are good for answers. So using our properties here, I'm seeing addition. So that tells us that we are going to rewrite this left-hand side as the log of x times x minus 3. And that's going to have to be equal to the log of 28. So that tells us then that we've got x squared minus 3x is equal to 28. So we're going to set that equal to 0 since it's quadratic, and we're going to solve. So we factor this, x minus 7 and x plus 4. And so we get that x is equal to 7, x is equal to negative 4. If we check these and plug in, if we plug in 7 in for x and 7 in for x minus 3, we find that that works. But if we plug in a negative 4, We're going to have a negative argument, so this is not a solution. So only the x equals 7 is a solution. Last example of this type. And actually, if you notice, this one's a little bit different. We have this extra number that's getting added here, so we've got to do a little bit of manipulation here. So we're actually going to keep this here. We can subtract this log of 2x plus 3 and move that to the other side. Now, using our properties, we see that subtraction, so that means we're going to rewrite using division. So we get log of 3x minus 4 all over 2x plus 3 equals 1. Now, this is actually not a one-to-one property. Keep in mind, there's no base written in here, so we can rewrite this as log base 10. It's what it's understood to be. So when we rewrite this as 10 to the first is equal to 3x minus 4 over 2x plus 3, and let's put that over 1. And now we can cross multiply and solve. So we get 3x minus 4 is equal to 20x plus 30. We're going to subtract the 3x from both sides. We're going to subtract the 30 from both sides. And we get that x equals negative 2. And if you go back and plug in, you're going to find that that does not work. So there is no solution. And that will be the case in some instances. Okay? All right. The other logarithmic equations that you see, we're basically going to rewrite using exponents. So we saw some one-to-one, but this last example we rewrote using exponents. And that's primarily what we're going to do. We're going to take advantage of properties as well a little bit. Notice this little note about how the directions might be read. So a lot of it just depends on whether we want exact answers, whether we're in the calculator section or the no calculator section of a quiz or a test for this. Okay, similar rules are going to be able to be applied here as we would in regular math problems. So if you notice here, this 2 out front, we can divide both sides by that 2. And so we get ln of x is equal to 9. And remember, this is kind of the key crucial step. I would suggest highlighting, stars, asterisks, something to help you remember. You're going to want to rewrite that ln x as log base e of x equals 9. And now we can rewrite and say e to the 9th is equal to x. We're just rewriting using exponents, and then we're solving. So this would be exact answer. If you were to plug into your calculator to get the decimal approximation, it would be 8103.08. Okay, on this one, if you notice, we have this number out front that's being added, so we're going to subtract that from both sides. So now we have a negative 3 log of 10x is equal to 6, and then we can divide by this negative 3, and we get log of 10x is equal to negative 2. And so keep in mind, in this case, our base is understood to be base 10. So we have a logarithmic equation we're going to rewrite using exponents. So 10 to the negative 2 is equal to 10x. And we know that 10 to the negative 2 is 1 over 100. And that's what 10x is equal to if we multiply both sides by 1/10. Then we find that our final answer for this one is 1 over 1,000. let's take a look at number 9. If you notice, there are a few things we can do with this one, a few different ways of handling that logarithm. Because of the exponent, but actually probably easiest on this one is truly just to rewrite this using exponents. So 5 to the 20th is equal to x to the 4th. And so we want to take the 4th root of both sides in order to solve. There is an alternative way of solving this. If we have 5 to the 20th and we raise that to the 1/4 power, then we just get that x is equal to 5 to the 5th. In other words, x is 31/25. There is an alternative way of solving this that I just kind of noticed that I'll talk to you about later. I really want to stick kind of with the same kind of pattern that we're seeing, so I don't want to confuse you too much. All right, this next one, if we rewrite using exponents, it's going to be 3 to the 4th is equal to 2x minus 2. So we get 81 is equal to 2x minus 2. So 83 is equal to 2x, so x is equal to 41.5. For number 11, 8 to the negative 1 is equal to 7 minus 2x. So this means that 1/8 is equal to 7 minus 2x. So we've got to subtract 7, and that I know confuses quite a few people. If we have 7 and we take 1/8 away from that, we're going to have 6 7/8, but it's going to be negative. And then we can rewrite this. Let's rewrite this as negative 2x is equal to 8 times 6 is 48 plus 7 is 55. So this is negative 55 over 8. And now we're going to multiply by a negative 1/2. So we get a positive 55 over 16. Or, as a decimal, that is 3.4375. All right, these last two, we've got to kind of deal with the properties a little bit differently. We've got to remember that we can rewrite that number out in front as an exponent. So to write this as a single logarithm, we're going to have log of x cubed over 2, and that's going to be equal to 5. Then we've got to remember our base. So when we multiply here, we get 200,000. We need 5 zeros and then multiply by 2 equals x cubed. So to solve, we're going to take the cube root of that, and so we get 58.48. And the last one here, log base 9 of x squared over 3 is equal to 2. Kids are coming out here. I'm going to have to pause. Okay, so using our rule for exponents, we know 9 squared is equal to x squared over 3. So 81 is equal to x squared over 3. In other words, x squared is equal to 243. When we take the square root of both sides, we get 15.59. All right, please make a note about questions you have over all of this, and make good notes about what questions you have on your homework, because we will review them when I get back.